So what is a factor theorem? Let us start with that. Factor theorem is generally used in long division. Okay, this is a utility. And when we are doing long division, so it involves some polynomial. So let the polynomial be px. Now the simple logic is that if this polynomial is divided by x minus a, and we say that if x minus a is a factor, logically, whenever there is any number, if it is a factor of another number, it means that when you are dividing a number by its factor, remainder comes out to be 0. For example, if I have 16 and I say 2 is a factor, so 16 divided by 2 is completely divisible and remainder is 0. So that is the logical meaning of factor. So factor theorem states that if x minus a is a factor of a polynomial px, then p of a is equal to 0. Now what is this p of a? P of a is indirectly remainder only. Why remainder? So here comes remainder theorem in picture. Okay, they are connected to each other like that. So when we say remainder theorem, I will get back to factor theorem again. Okay, don't worry. We'll discuss both the things again. So when we say remainder theorem, so in remainder theorem, it is said that if px is a polynomial and it is divided by x minus a, and x minus a is not called as a factor of it, okay, whether it's a factor or not, we don't know, then p of a will be equal to remainder. I repeat, if a polynomial is divided by a factor, then that factor, when you will equate it to 0 and get the x value, at that x value, the polynomial will give you remainder. If putting that x value, polynomial gives the remainder as 0, then we'll say that x minus a was a factor. Let us go back to factor theorem again. So that is a factor theorem. So factor theorem, remainder theorem are kind of similar, only the names are different. And you should understand what is the real meaning of factor. If it is a factor, then it will make remainder 0. That's why we say PA is 0. And if it is just a term which we are dividing, like if px is divided by just a term x minus a, which we may not know whether it's a factor or not, then it will just give me a remainder. If remainder is anything not equal to 0, then x minus a can never be a factor. Okay, so it happens many a times that when we are dividing a polynomial, we do get some non-zero remainder. It means that the polynomial which we are dividing now, px, is not perfectly divisible by x minus a. So then remainder theorem is used.